Okay, let's look at paper 2. Normally question 1 and 2 in paper 2 will be probability ones, maybe the Venn diagram and the inferential statistics, the hypothesis testing. But if they're not like that, they might look like these. This first one is about experimental probability or relative frequency, where the idea is that you have a number of people testing to see if a coin is biased or not, or dice is biased. Okay, so they'll throw it a number of times, and they'll get, the event they're looking for is heads, and they'll count the number of heads for how many times they've thrown. 500 times for Lucy, and she got 291 heads, and they think the coin is biased based on the results. Why might they think it's biased? Because they're all getting more than 50% heads. Okay, probably just getting ahead is 0.5, and they're getting more than that. Then Lucy uses all the above data and calculates the best estimate of the probability, or the experimental probability, or the relative frequency of throwing a head. She gets 0.58. How did she do that? Well, she added up all the number of heads that were tossed, and she added up the total number of tosses, and she found that with this coin, the probability of getting a head, or the experimental probability of getting a head, was the number of heads divided by the number of throws, 0.58, and there it is there. P event, number of desired outcomes over total number of outcomes. Joe agrees with Lucy's estimate of 0.58 as the probability of throwing a head with this coin. He claims that the probability of throwing 3 successive heads, so we're going into Bernoulli trials now, without this coin is less than the probability of throwing 2 successive tails. So calculate the probability of each. Okay, so the probability of getting a head with this coin is 0.58, and therefore the probability of getting a tail is 1 minus that, because the two will add up, is 0.42. Okay, so he's saying we need to calculate the probability of getting a head and then a head and then a head. So that's, otherwise that could be PHH, or if we said a head was a success, P success, and that gives us this value here, because we multiply the probabilities. Or the probability of getting a tail and then a tail, that's 0.42 by those. So Joe's claim is untrue because he's saying that the probability of throwing 3 successive heads is less than the probability of throwing 2 successive tails. So 3 successive heads is 0.195, and the probability of getting 2 successive is 0.176. This is actually greater than. So that should be is not less than. Okay. So question 2 then was about generating sample spaces really, but to begin with, you're given a spinner and you're asked to find, and the spinner has 2 green sectors on it and 3 red, 5 in total. So you're asked to find the probability that it stops on green for 1 spin. Well, that's 2 and 5, and the probability of stopping on red would be 3 and 5, because the 2 would add up to 1. Okay. Then we're asked to list all the possible outcomes of 3 successive spins of the spinner. Okay, so I like to do this, bear with me, using a tree diagram. So you have spin 1, it can go red or green. Spin 2 then can go red or green. And spin 3 can go red or green. Red, green, red, green. So this spin 1, spin 2, spin 3. So this and this and this is red, red, red. And this is red, red, green, and so on. And you can work out the probabilities of each of those as you're asked them. Now they ask us then, they tell us that the game consists of spinning the spinner 3 times. Each time the spinner stops on green, the player wins €1. Otherwise the player wins nothing. For example, if the outcome of one game is green, red, green from your list over leaf, then the player wins €2. So complete the following table. So the player wins no euros, so you have to look at the required outcomes. So each time stops on green, otherwise the player wins nothing. So 3 reds is a definite nothing. So you just fill in the table accordingly, according to the rules here. And finally we're asked, is one spin of the spinner an example of Bernoulli trial? Yes, it is. Why is that? Because it's an experiment whose outcome is random, and it has two possible outcomes actually, success or failure. So that's the reason. Now we always say for Bernoulli trial also one outcome is independent of the other, but they're just talking about one spin here, so that's good enough in this case. Question 3, paper 2 then kind of looks at the line. So L is the line given in the form something x something y plus 18. Find the slope of L. Okay. Well, that's the skill that you have to rewrite this in terms of y equals mx plus c. So you leave your y there, you bring both of these over, and then you divide both of these terms by 2 to get minus 3 over 2 and minus 9. So the slope is always the coefficient of x. Slope of that line is minus 3 over 2. That's a nice question. It's a skill you definitely need to know. Then the line k is perpendicular to L, so automatically you're thinking the slope of k is the inverse of this with its sign changed. Okay, the inverse of that with sign changed. And we're given a point that it goes through, so find the occasion equate. Well, we know slope of L, so we now know the slope of k, invert it, change its sign. You have a point 70, that's your x1, y1, and your slope. Plug it into y minus y1 equals m by x minus x1, and you should end up with something that looks like this. Okay, so you cross multiply this y by the 3 to clean that, and so you end up with 3y equals 2 by x minus 7. 3y equals 2x minus 14, and we give our answer always in terms of something x, something y, and a number is equal to 0, but that something x is positive. Okay, so it's on this side, so we brought that over. If the x was on this side, we bring everything over towards that side. Then, find the coordinates of the point of intersection of the lines L and K. So basically all you need to do there is solve the two equations simultaneously. Okay, so we have 3x plus 2y plus 18 equals 0, 2x minus 3y minus 14 equals 0. So we're looking to kind of nail the y's here. So we'll multiply the top line by 3 and the bottom line by 2. That gives us 6y above and below. So they'll cancel. 9 plus 4x is 13x, plus 54 minus 28 is plus 26. So 13x equals that, x is minus 2. And we put that back into any of the equations to find y equals minus 6. So the point of intersection is minus 2 and minus 6. Now let's look at the circle. Okay, so question 4 follows, hopefully you get the line question and a circle question. They don't just mix them all up into one. But anyway, the point A, which is here, has the coordinates 8, 6 and 0 here is the origin. So we have two circles there. The diagram shows two circles, C1, C2. C1 has center, the bigger one has center at 0, 0. So its equation will be x, something like x squared plus y squared equals r squared. Okay? Whereas the other circle here will have a different equation. Okay, given by a different formula which we'll see in a moment. But anyway, we're asked to find the equation of the larger circle. Okay? So we know that the origin's at 0, 0. We have a point out here on the circle at 8, 6. So we can use that point, and we'll use that point to help us find the radius r of the circle, because that's the distance from from O to A. Okay, so from the line coordinate geometry, the line chapter, the distance between O and A, which is the same as r, is found by, y2 minus y1 equals x2 minus x1. This is x1, y1, x2, y2, and that's what we've kind of named here and here. And we find that that distance is 10. So therefore the centre is 0, 0, the radius is 10. So the equation of that circle must be x squared plus y squared plus 10 squared, which is equal to 100. Then we're asked to find the equation of C2, and we know that the centre of C2 is the midpoint of OA. Okay, so because this is bear with me now. Sorry, this is OA, and the centre is at the midpoint OA. And how do we know that? Because it says it here. C1 is centred there, and C2 has a diameter of OA. So the centre must be at the centre of A. If that's the diameter, that represents the radius of that circle. Okay. So therefore, looking for equation of C2, we know that we have the point O and A, and we want to find the midpoint of that, and that's at 4, 3, using the midpoint of the formula. We know the radius must be half of OA, that must be 5, and so the centre HK is at these coordinates here, so that's H, that's K. The radius is 5, and so we use the formula x minus h squared plus y minus k squared is equal to r squared. Okay, so we plug in our h here, and our k there, and our r squared there. So we get x minus y squared plus y minus 3 squared equals 25. Finally, we're told that the circle C2 cuts the x-axis at the point P. Find the coordinates of P. Okay, so we'll have to see what we're talking about here. So this is the circle C2. We have to find the coordinates of that point P. How do we go about that? Okay, well, we know that the equation of the circle is given by this. We've just found that. And that equation would cut the x-axis at y equals 0, or it would cut the y-axis at x equals 0. But we're looking to see where it cuts the x-axis, because we're looking for the point P. So we simply let y equals 0, which is here, and we generate a quadratic which looks like this, where we have x minus 4 all squared is equal to 16. So x minus 4 must be equal to the square root of 16. X minus 4 is equal to plus or minus 4. So we can equate x minus 4 to plus 4, and we get x equals 8, and we can equate x minus 4 to minus 4, and we get x equals 0. Okay, so we're going to reject this one because we know that this point P, it's not at x equals 0. It's more likely that's x equals 8. Okay, so the point P is at x equals 8 and y equals 0. Okay, so we have an area volume question here. So talk about solid cylinder, radius 10, height 45. Draw a sketch of the net as if we were to fold out the cylinder, the surface of the cylinder, and write its dimension sketch. So in this example, we suggest that you let each square equal 5 millimeters, because you are given dimensions there. That would be 2 squares, that would be 9. So here's our 9 squares, there's our 2, 2, 2, 2. Okay, so that's 10 mil radius. And then we can calculate this dimension here, because this is always 2 pi r, and that's equal to 62.8, and you measure that accordingly. Okay, giving 5 millimeters per square. Now we're asked to calculate the volume of the cylinder. So from your log tables, volume of the cylinder is given by pi r squared h. R is 10, your height is 45, so your answer in terms of pi is 4,500 pi millimeters cubed. So try not to forget the units if you're given units in the exam. Okay, and then finally, a sphere has the same volume as the cylinder. Find the surface area of the sphere. Give your answer in terms of pi. Well, the volume of the cylinder is equal to the volume of the sphere. So 4500 pi is equal to 403 pi r cubed, which is the formula for the volume of the sphere. So we're trying to isolate r cubed here, so we'll cross multiply the 3 by this and divide by 4. So we get 3375 equals r cubed. So now we need to find the cubed root of 3375, because that will give us r. So you can work that on your calculator using the, where is it? Use Shift X, that button, and that allows you to type a 3 in here for the square root sign. And so your answer r is 15 millimeters, so therefore the curved surface area of the sphere is this formula here, but your r in there is 15. You get 900 pi millimeters squared because it's area. So then the constructions and enlargements question around question 6 in 2013 was to construct a triangle. So you're given AB as 8 centimeters and BC and AC both 5 centimeters. So you just draw a line, measure 8 centimeters, set your compass to 5, strike, set your compass to 5 and strike, and you get your triangle of 8, 5 and 5. Okay. On the diagram then, construct the image of the triangle ABC under axial symmetry in AB. Well, basically AB is there. We're going to draw this triangle in axial symmetry through AB. So there's no measurement to do there, so that point is fixed, A prime, B prime, but we do measure from here to here, and we bring this line through at 90 degrees to this line here, and we measure the same distance to C prime. So that is the image A prime, B prime, C prime of A, B, C. Then we're asked to justify the statement that this is a parallelogram. Okay, and it is a parallelogram because the diagonals AB, okay, that's one diagonal there, and C prime, the other one, bisect one another, okay, because these are actually the perpendicular bisectors. So they bisect each other, therefore this must be a parallelogram. Now, the geometry question in 2013 asked you to prove that essentially these three angles were equal to 90, and the solution involves numbering the angles, realizing what numbers you're looking to prove equal to 90, and working through the proof. So I can let you can read through the proof yourself, and you'll see how they derived this solution. Okay, so just also remember for the geometry question, really more importantly, really, that was a tricky enough one that year, but you have to know about the alternate angles, the sum of interior angles, corresponding angles, angles that straight line angles at 180, angles at a point add to 360, two straight lines that intersect, this angle is equal to that and that angle is equal to this. So you have to know how to angle chase for the geometry one, because it will be, the clue will be in the diagram they give you. They might have all sorts of bits and pieces going on, but actually that would be equal to that, or this will be equal to that if these are parallel, and so on. So familiarise yourself with my checklist before you meet with paper 2. So question 7 in 2013 was a nice statistics question. So you're given all the data there, and if we move on then, you're asked to draw a back-to-back stem and leaf plot for the data overleaf, and this is what it should or did look like. Okay, and then you're asked to state one difference. Now I've actually written the difference down here. State one difference that can be observed between the distributions of the marriage rate and the death rate in your plot. So the rates from 43 to 52 grouped at the top of the plot, and the death rates range from 61 to 90 grouped at the bottom of the plot. So just state the obvious with respect to the data. Don't forget when you do your stem and leaf, you have to do your key, so don't forget your key. And then find the median and the interquartile range of the yearly marriage rates. So we're looking to find the median of this data here. So always the trick is to count how many pieces of data you have first of all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So our median must be in the middle of all of that, and if it's 21 it must be the 11th one, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median is the middle value, it's 50. Then we're asked to find the lower quartile Q1, the upper quartile Q3, and the interquartile range, the difference between them. Now, in this situation here, my median is bang in the middle of the data. So to find Q1 and Q3, let's find Q1 first. I cover that up and I count that. I note that I've 10 bits of data here. So my Q1 of this data is like finding the median of these 10 bits of data. So it's 1, 2, 3, 4, 5 and 6. It's the average of those two. There it is there. And then I look this way, then I have 1, 2, 3, 4, 5 and 6, the average of those two. Remember, it's 51 and 52. They're there. That's Q1, Q3, and my interquartile range is one minus the other. So just be careful. Two things. Be careful when you're reading off the stem and leaf that you read that way. That's why they asked you that one rather than this way, I think. And also, if you struggle with the stem and leaf, just list the data in ascending order, and you should be able to find Q3 and Q1. Now, sometimes when we have data and with an even number of data values, and with 8 pieces there, say, and our median is the average of these two. When I'm looking for Q1, I do include 1, 2, 3, 4 bits of data there, and I find actually the average of those two, and I include, looking for Q3, 1, 2, 3, 4 bits of data there, and that's Q3 there. So just be careful. There's a line dividing it. You count from the line. If it's in the middle of the data, you cover it and count both ways to find Q1 and Q3. Then you're asked to find the mean of the death rate. So you add up all the numbers of deaths, and you have 21 numbers or years or whatever it was. So the mean is 78.3. That's the mean of the death rate. The question goes on to give you the standard deviation of the death rates as that, and you have to list all the death rates that are within one standard deviation. So the mean is this, standard deviation, that's your range is the mean minus the standard deviation, comma the mean plus the standard deviation. So it goes from 68 to 88.6, and you list them all like that. Okay. Then we're in this part where asked in 2010 the number of children born in Ireland was 75174. Use this number to estimate total population. So you equate 165 births in 2010 to 10,000 people. So one birth is that many people. So that many births must be a population of that many. Okay. And for the other way around, then use your answer in E here to estimate the number of people who died in 2010. So in 2010 there were 61 deaths, 10,000 people. So one person would equate to 61 over 10,000 deaths. So if we multiply that, or get the fraction of that, of the population by multiplying it, it's that fraction of the total population. That means there was 27,791 deaths out of the total population. Okay. And then finally, more children were born in Ireland in 1990 than in 2000. Given reason based why the statement's not necessarily true. The birth rates given per 10,000 of the population. If population in 2000 is greater than the population of 1990, more children could have been born in 2000 than in 1990, even though the birth rate in 2000 was lower. So look, don't worry about these last three bits. They're kind of tricky enough really to to get through. So just do your best with the early part of the questions, the means, the stem and leaves, the standard deviations, the interquartile range. Just get those basics right and you're mostly there. And then there's a bit about ratios. Find the ratio, that is the birth rate to the death rate for the years 1990 and 2010. So that's the birth rate to the death rate there, and for 2010 it's there. Based on your answers for the 2 years, what would you predict about the population of Ireland in the future? Well, you know, the population is expected to increase, okay, because more children are being born for each person that dies, okay. And then you're given a scatter diagram for a finish, and you're asked to the birth and death rate 21 years are plotted against each other in the scatter plot. The correlation coefficient between the two sets is minus 0.85. That's ours minus 0.5. Remember, goes from minus 1 if it's really close to plus 1, and anywhere in between are the correlation coefficient. Describe the relationship between the two sets of data. So the sort is plus 1 equals minus 1. Between two sets, it's just the reason why this might be true. So the suggested answer there is that there's a strong negative correlation. Well, if it's minus 0.85, it's definitely strong. It's close to minus 1. And then you can say that with increasing birth rate, the population is getting younger and the death rate is declining. So the last question in 2013 was the trigonometry question, and you know, with the trigonometry questions you have to be able to recognise the angle that's at play, I suppose, for want of a better word. So in this problem, a search has begun for a buoy that has become detached from its mooring at sea. The area to be searched is a radius of 30 kilometres from last known place K. The buoy, the searcher is divided into 6 equal sectors, so 360 divided by 6 must mean 60 degrees in the sectors here. Okay, so you need to spot those ones. And there you go. Find the angle, find the size of the angle BKA. So BKA, and the answer is 60. Find the area of the triangle KAB, so that's this triangle here. The area of the triangle KAB, you know this side is 30. Sorry. You know that side is 30. You know this side is 30. You know the angle in between. So you can use this area of a triangle formula and you get 389.7 kilometres squared. Then you're asked to write the area of the triangle as a percentage of the area of the sector. So you have to use the area of the sector formula, okay, which would be 60 over 360 is 1/6 by pi by the radius squared is that. The area of the triangle KAB divided by the sector KB times 100, it's 82.7%. So the triangle accounts for 82.7% of the sector KAB. Then they give you the they say use the cosine rule to find the length of AB. So you can work that, you know, if you're 30 here and there, because AB is here and that's 30 and that was 30, and that's 30 kilometres also. So what does that tell you about the triangle KAB? Well, you know, it's 3 sides the same length, so it's an equilateral triangle, so all the angles are 60 degrees. Okay. And then finally we're getting close to a helicopter took part in the search. The helicopter flew from the point F around the perimeter of the search area. What distance did it fly? Correct nearest kilometre. So it flew from F and it went all the way around. So you're looking for the circumference of the search area, which is 2 pi r. You know r is 30, 188 kilometres. The helicopter then flew in a straight line from F to D and D on to C and straight. I'll draw that in the thing. So that's drawn there. Okay. Now you should recognise that that's 90 degrees because the angle in a semicircle is always 90 degrees. Okay. There it is there actually, sorry. A theorem on your course. can be used to find FDC. Write down the angle FDC, which is here, and state. So it's 90 degrees, i.e. angle in a semicircle is 90 degrees. The helicopter flew at a speed of 80 kilometers an hour. How long did it take to fly from F to D and on to C? So F to D and on to C. So triangle FDC is a right angle triangle, so we can use the trig ratio because it's a right angle triangle, and we can find that the total distance is 81.96. Speed is distance over time. It went 81.96 over 80 kilometers per hour. So therefore our answer is, so it's a bit small for me to see, is 1.0245 hours, or 61 minutes and 47 seconds. So a lifeboat taking part in the search sailed in a straight line from the point K until it reached a point X, the midpoint of ED. Calculate the distance KX. Okay, so we have to consider triangle KEX, and we can see that that's 60 degrees now already is equal to KX over EK using the trig ratios because it's a right angle triangle. So therefore we can find that this distance is 25, KX is 25.98 kilometers. So we've that bit solved. Okay, the buoy was located at the point where the path KX of the lifeboat crossed the path FD. So that's where the buoy was located here. Okay, how far was the buoy from X? Okay, so we call P the point of intersection. Just to slim this down a bit. We'll call P the point of intersection there, in here. Okay, of the paths of the helicopter and the lifeboat. So now we have to think about FKP, this little triangle in here. Okay, and we know that this is 30 degrees here. Okay, that's 30 degrees, so we can use the trig ratio there, and we can find a value for PK at 8.66 kilometers. Or another way of looking at it was to look at the triangle DPX, so DPX, that little triangle there. And again, we're using the fact that the angle 30 degrees allows us, if we use the trig ratio for the tan of 30 degrees, we can find PX equal to 8.66, which is the same answer. Okay, so look for right angle triangles, and then either Pythagoras is there if you need that, and know that that's the hypotenuse of two angles. Some of the angles is 180, and you use your some old hens cackle all hours till old age. So in trigonometry, you have to know the angles you're starting off with. You have to know what an equilateral triangle is, isosceles triangle, and but really you're looking for right angled triangles or non-right angled triangles. If it's right angled, it's Pythagoras and all of this. If it's non-right angled triangles, then you're using the sine rule, the cosine rule, and the area of a non-right angled triangle rule. They're the three main ones. They're in the logbooks. They're on your list of skills. Okay.